Hello everyone. In the earlier video, we got to know about the optical isomerism, what is optical activity, and criteria for optical isomerism. Okay, we got to know that the chiral carbon is a carbon having 4 different groups which are attached to that carbon atom. Okay, means when the different groups are attached to the one carbon atom, that carbon atom is called as chiral carbon. Okay, then we shall discuss about configuration of that chiral carbon. You have to give the configuration, means the spatial arrangement of atoms of that carbon. Okay, how the atoms are arranged in space to that carbon atom is called as configuration. And there are two types of configurations. One is relative configuration and the absolute configuration. What is the relative configuration? Relative configuration is here. The D and L are the relative configurations. Small d, small l, plus, minus, R, S, E and Z are the absolute configuration. What is the difference between the relative and absolute configuration? Means D and L, there we know that in the glucose structure, CHO, this is structure of glucose. In the structure we use that this is D glucose. Okay, the meaning of D is not dextrorotatory. The meaning of D is it is relative configuration. Relative configuration means the configuration relative to another compound. Relate with this D glucose is relative to glyceraldehyde. The structure of glyceraldehyde is this one. This is D glyceraldehyde. So in relative to this D-glyceraldehyde, we have to give this absolute relative configuration to this glucose, because here you have to check this carbon atom next to this, means next to this CH2OH, this carbon atom, to this carbon atom OH is on the right side. So we have to compare this with this. So this carbon atom, that is fifth carbon atom, OH is at the right, on the right side. So OH is on the right side in this glucose, which is relative to D-glyceraldehyde, where the OH is on the right side. So that we have to give this relative configuration as D. Like this, that D-glucose gets the D. That is the relative configuration. And L, when the OH is in the left side, you have to give the L-glucose. Okay. This is a relative configuration. This is not the dextro, there is no relation between dextro and levorotatory to this relative configuration. Then absolute configuration, here there is a exact configuration around the chiral carbon atom of the groups attached to the chiral carbon atom. This is dextrorotatory, levorotatory. This is also dextro, levo, R and S, E and Z. These are absolute configurations. In this video, we shall discuss about R and S configurations. So absolute configurations R and S are when the molecule is optically active, whether this rotates to the right side or to the left side. That decides by this absolute configuration. Means R, meaning of R is rectus. The meaning of this is means right side. And S, sinister, means left. So when the molecule is optically active, if the configuration of that molecule, of the configuration of that chiral carbon is R, then its meaning of that is it rotating the light to the right side. And when it is configuration is absolute configuration is yes, it is rotating the light to the left side. So that you have these configurations are very important. Meaning of R is rectus. R means rectus. The meaning of rectus is right side. Means when you don't when the configuration R, it means that it is right side rotating. When the S is the configuration, meaning of that it is rotating the left side. Okay, then what are the criteria to give the configuration to the molecule? We know that the carbon, this is what first one, the carbon, this carbon is chiral carbon, because see, this is Br, OH, CS3 and H. All the four groups are different, so that this carbon is chiral carbon. The first rule is, first thing, we have to give the numbers to the groups. We have to give the priority numbers to the groups which are attached to this chiral carbon atom. Means here OH is attached, CS3 is attached, H is attached, and Br is attached. So that first we have to give the priority to the each atom which is attached to each group which is attached to this carbon atom. So how you can give the priority number? It depends upon higher atomic number atoms attached to the chiral carbon gets the higher priority. Means here hydrogen is attached, here oxygen is attached, here Br is attached, here is carbon is attached. The atoms which are attached to carbon whose atomic number is high, the higher atomic number gets the higher priority. So here the Br having higher priority, hence the priority of Br is 1, next oxygen, next carbon, and the fourth one, that is hydrogen. So because atomic number of hydrogen is less than the carbon is less than the oxygen is less than the Br. So Br is having higher atomic number, hence Br gets a first priority. Like this, we have to give the priority number to the atoms or the groups which are attached to chiral carbon. And the priority, I will write the priority order here. So iodine gets the first priority, then Br, then Cl, and SO3H, then fluorine, OCOR, then OR, then I'll write here, then OH, then NO2, NR2, NHCOR, NH2, CCl3, COCl, COR, COOH, CONH2, COR, CHO, CN, C6H5. This is the priority order of the groups attached to the chiral carbon. Means if you are having I and Br, you have to give the one number to this iodine, then Br. Sorry, this is not oxygen, this is deuterium. This is deuterium. If you have COH and C6H5, you have to give number 1 to COH, then C6H5. This is the priority order of the groups. Then what is the next rule? Next rule is, if the atoms, first atom which are attached to this chiral carbon, here also it is chiral carbon, here also it is chiral carbon. If the two groups which are attached first to the chiral carbon are same, then we need to look for the next atom. If the second rule is, if first atoms attached to chiral carbon are same, then we have to go for the next atom. Means if the two groups which are attached to chiral carbon, those are containing same atoms, same first atoms, then we have to look for the second atom. See here, this is OH, CS3, H and CH2, CS3. OH, here the OH gets the higher priority because carbon is gets the lowest priority. Here, this is also having carbon, this is also having carbon. But this carbon, it makes a one bond with one hydrogen, another bond with another hydrogen, one bond with this carbon. So that this directly attached to 3 hydrogens, but this attached to 2 hydrogens and 1 carbon. So that it gets the second priority, and this gets the third priority, and this gets the fourth priority. Okay, here the OH, carbon, hydrogen, carbon. So OH gets the higher priority, and here this COH, hydrogen, carbon. This carbon, when you look for the first atom, both are same, but this carbon is attached to oxygen here. This carbon is attached to hydrogen, so that this is second, this is third, and this is fourth. Like this we have to give the priority number to the atoms which are attached to chiral carbon. Then third one, after giving priorities, we have to move from 1 to 4, means 1 2 3 4. We have to move from, we have to look for 1 2 3 4, and if the movement of this 1 2 3 4 is clockwise, then the configuration is R. If the movement of the 1 2 3 4 priority groups is anti-clockwise, then it is S configuration. See, this is S configuration and this is R configuration. If it is clockwise, then it is R. If it is anti-clockwise, it is S. Here this is 1, it gets 2, it gets 3, and it gets 4. So here it is 1 2. We have to move from 1 to, it is R. The movement of 1 2 3 4, it is R, hence it is right side, hence it is R configuration. Here it is 1 configuration, it is 2, priority 2, priority 3, and priority 4. This is 1 2. So this is anti-clockwise movement, hence it is yes. Like this we have to give the configuration. Next one, an important rule is, when the lower priority groups is on the horizontal line, then we need to reverse the configuration. Means we should assume that these two groups are nearer to the, these two groups are nearer to the, near to us. These two, this line is, vertical line is away. So the lower groups always should be in away from the observer. Higher priority groups always nearer to the observer. If the lower priority groups are nearer to observer, then we should reverse the configuration. Got it? See, always higher priority, higher groups always should be nearer to observer, and lower priority always should be away from observer. Means these are nearer to, these groups are nearer to observer, these are away from the observer. But when the case is the lower priority group are nearer to the observer, then we need to reverse the configuration. See, first we have to give the priority number. So OH gets 1, CS2, CS3 gets 2, CS3 gets 3, and H gets 4. Check the priority group. OH is nearer, priority number 1 is correct. Here hydrogen is the lower priority, but it is in the nearer to the observer, means it is in the horizontal line. So that here we need to reverse the configuration, means 1 2. Actual configuration is R, because it is right side. R 1 2 3 4 is right side, but the lower priority group is on the horizontal line, hence we need to reverse the configuration to S. Hence this is S2 butanol, not R2 butanol, because the the lower priority group is in the horizontal line. Just check for this. This is 1 2 3 and 4. Here also the fourth group in the horizontal line. 1 here, the actual is 1 2, so that it is S, but the fourth is the lower priority group is in the horizontal line, hence we need to reverse the configuration to R, hence it is R2 butanol. The next one, this is 1, this is 2, this is 3, this is 4. It is 1 2 3 and 4. So it is, we have to when we have this case, then we should not go for 1 3. Always we should go for 1 2. Okay, by passing 4, because 4 is the lower priority. We should not bypass the 3, we should bypass the 4, lower priority, hence we move to second by bypassing 4, so that we will get 1 2 3. So that we are going to get 1 2 3. We should not go bypassing 3. Okay, 1 2 and 3. So this will be yes, but the lower priority group on the horizontal lines, hence it should be R, hence it is R lactic acid. then this one 1, 2, 3 and 4. Here in this case again we should not go by 1, 3, 2. We should go by 1, 2, then 3 by bypassing 4, so that it will be R, right side R, but lower priority group on the horizontal side, horizontal line, hence it should be S. Hence lactic acid is S lactic acid. Okay, like this we should give the configurations to the chiral carbons. Okay, thank you.